Uh, organic. So I could actually give you guys more questions for the organic structures just for practice. So I'll set up a practice module for you guys, and then I'll email you when it's done. Put that on my notes. What else should I tell you? Let's see. So,
Dr. Henry, before you start, so for the exam will be open until Friday, but when is the last date to do it? Is it just Friday only or until
no.
Tuesday?
Does anybody want to tell them what the last day was?
Tuesday.
Tuesday.
Missed it.
Oh,
What do you mean was? Did I miss an exam?
Yeah, you missed it.
Are you talking about exam 2 or exam 3?
Exam 3.
Oh man, whatever. That's all right. You know, top 6. I'll just that'll carry.
So are you just gonna coast the top 6 the rest of the term? Is that what you're telling me?
Yeah, you know, say I can miss an exam. It's all right. I'll be all right. No, what happened? What closed on Sunday?
Nothing closed on Sunday.
Tuesday.
Does anybody want to explain to Nate what I just said?
I was only 2 minutes late, Dr. Henry.
That's what you get for being 2 minutes late.
Well, I figured on average you're 15 minutes late. So if I'm 2 minutes
I'm
late,
never 15 minutes late. If I'm late, I'm usually an hour late. You gotta get it right.
He's either here or he's not.
I thought I
Yeah.
was slide right in under the radar.
Nay, we were talking about the coming exam. That's why.
But what closed that we missed? What did you?
Nothing.
Oh, nothing closed.
Oh, okay. All right.
He was asking how long will I have to take the exam? So you'll have Friday until Tuesday to take the exam.
Friday to Tuesday. Okay, sounds good.
Okay, so first, let me make a correction. I called these structures that have the alkali, the halogens on it. I call it alkali halide. They're not alkali halide. They're just called. Let me see. They're called halo alkanes. And they are the lowest on the totem pole. Then we have alkanes. Then we have alkynes. Then we have alkenes. Then we have amines. Then we have alcohols. Okay, so what I'm going to do is I'm going to give you the functional groups of these, and then I'm going to add a couple more on here. And if you're able to find their functional groups, of course, I say that and I can't find mine. Yes? No, maybe?
yes.
Aren't you supposed to put up another printout for us?
Yep, there is a printout under resources.
Where's that at? Let's see.
Under the modules resource tab.
Okay.
You found it?
Functional groups.
Functional groups, yep.
All right. Thank you. Is there anything else we need to print for the test or just this extra sheet?
You should just that extra sheet. Of course, you should have your periodic table and all those things as well, right?
Yeah, I have everything up until now, but I just want to make sure for the test, this is just the extra sheet that we need to print.
Yep.
All right. I'm gonna email my girlfriend's mom since she's the only person I know that still owns a printer.
Nobody else owns a printer?
Man, it's 2021, man. Nobody got a printer.
Nobody got a printer? Nobody needs a printer?
Pull this up on my iPad, you know what I'm saying?
Oh, I see, I see.
But now we got this crazy test. You can't pull it up on your iPad. They think you're trying to cheat.
Okay, so
Good
the next,
functional groups, right?
what was that?
Well, which printout was it? You say functional groups?
Functional groups, yes.
Okay.
Okay, so the next functional group that we're going to be talking about is called ketones. I have a lot of people messages. Good. Okay. So ketones look like this. So R represents functional groups, right? It could basically means hydrocarbons or anything that's there. But the general structure of a ketone is okay, so this is what a ketone looks like. The suffix of a ketone is an "-one", as in ketone. The prefix for ketones, yeah, let's see, is oxo. And the way that we do ketones is we just count the carbons. So this is the way that it's going to be drawn without drawing the C. And you just tell where the double bond O is located at. There always has to be a carbon at the end. You can't put it at the end because that's a different function. I'll show you that one here. Okay. So like in this case, the length of this carbon is 1, 2, 3, 4, 5, 6. So we would call this guy, what is a 6-chain carbon? What is that prefix for a 6-chain carbon?
Hex.
X.
Okay. Hex, unknown. And then we put 2 because it's the second carbon where the double bond is at. So that'll be 1. Oops.
Doesn't known mean 9 though?
The prefix known means 9, but ONE at the end means it's a ketone.
Okay, that's not confusing. They couldn't switch it up a little bit.
Well, you can take it up with them, you know. You got a lot of people to take it up with. I can't control that. I'm just giving you the name.
I thought it said 6-9.
Okay, so if we have this guy,
One, two, 4, 5,
what is that guy called?
4, 5, 6, 7. Hepta? Known? Oh, wait. 1, 2, 3, 4. 4 heptanone? Is it even hepta?
That's right. So it'd be 4 heptanone. Okay,
4 heptanone.
Would you be able to do the same thing with alcohol and put iso in front?
yes. So let's say, or an isoheptanone, technically you should be able to do the same thing with the heptane as well. Yes.
That was probably Edgar jumping ahead, huh?
Of course it is.
I don't even have to see his name. I already know.
Okay, so let's see, what will we name this guy?
1, 2, 3, 4, 5, 6, 7, 8.
Let's do
4. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 7, 8. 4, 5, 6, 7, 8, 1, 2, 4.
Oct- Oh, yeah.
Chain
Or
4. No, it's a 4 because double bond comes first.
yeah, wouldn't be 4, 2, octa,
But that other chain,
and
that other chain's a different chain though, isn't it?
It just looks like a methyl.
Yeah.
So I would put methyl first, just because it's separate from the other one. So I'd put 2
Right.
methyl.
2
2 methyl. Is that what you're saying?
That's what Edgar's saying. I
Okay.
thought bonds came first.
that's
I thought we named double bonds first, but I could be wrong.
It's
Now, remember, it's a special type of double bond. It's double bonded with the oxygen. So that makes it a known, right?
Oh, so that would be at the end then, huh?
Yeah, that's right.
4 octanone. So it's, yeah, I agree with Edgar.
Oh, kicking
One-
and screaming. You agree with Edgar?
With this one time, I'm gonna give it to Edgar.
And then you were right. Was it Tucker that said octa?
yeah, octa, whatever. Yeah.
Yep.
But real quick, again, what is it? What makes it a methyl?
A methyl?
Methyl, yeah.
Okay.
Like
When it has one single chain carbon coming off the main
Okay.
chain. Right? We have that
Okay.
one single chain carbon coming off the main chain.
And again, Dr. Henry, before the methyl, the 2 means where the methyl is located, right?
That is correct.
Okay, then. Thank you.
Okay. How you feeling so far? You got it? You ready for another?
Yeah, can we do ketamine next?
Hey, you already know how to do ketamine, actually.
What comes after the 4-octanone? I can't see it on my end.
Do you want me to raise it up? Is that what you're
Yes,
saying?
please.
You see it now?
Yeah, thank you.
No problem. Yeah, I keep forgetting that I have a really big side screen to work on, and you guys all don't have that.
Humble brag right there. A little humble brag.
Well, you know,
Sorry, I have 4 monitors curved.
I'm working on the 4th one. You know. Okay, so then above the ketones, and it's funny, you guys have heard of ketones before and everything like that. So you've heard a lot of these terms just thrown around. You just never know the chemical structure. Right?
Okay,
We have aldehydes. Okay, so aldehydes its suffix is going to be al, al. So aldehydes look like this. Generally, and that carbon there, and then this is going to be a hydrogen here. So it always has this hydrogen attached to that carbon. And then we have our functional group. Okay, so these are always kind of terminal, meaning that they're at the end. So
We have our function.
This is the way it'll look. It's drawn out.
OH. When you say we have our functional group, is that everything coming off of the, so like that R represents the 1, 2, 3, 4, that 5 carbon chain?
That's right.
Okay.
Yeah.
It's just like an
But you count that carbon. You count this carbon is always going to be your first carbon.
you count the carbon that's connected to the hydrogen and the
That's right.
ketone.
Yeah. That's going to be your first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon.
Okay.
Okay. This guy would be called, what is a 6 carbon chain? Start with,
Hexa.
X.
man, I'm stuck on 6 today. So this guy would be called hexanal.
Hexanal. Wait. Now. Oh, formaldehyde.
Yep.
Hexa. Where's the N? What's the N? Is that just to tie it all together?
Yeah, because there's only single bonds here, right?
No, I know there's hexa and then there's al, but there's like an N. How do we know when to throw that N in there?
Because hexa is just the prefix, right? The
Right.
N, the AN lets us know that this here lets us know that they're all all single bonds here.
Oh, and okay.
Yeah, but don't forget, you got to keep track of whether there's doubles or singles in there.
Oh, if that was like a hex in now, like INAL or whatever, it'd be like a double bond in the
And you
chain.
got to tell me where it's located. So I could also have this guy.
So would it be like hex 2 in al, like that weird writing?
Yes, that's what we're going to do.
Okay. I got you.
So that's 1. Oops. 1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. Hex 3 in, right? Oh, in. And now, okay. And now,
Okay.
sure.
Double
So-
bonds, right?
What was that?
Double bonds, right? At
Yep.
the beginning of 3?
Yep.
Okay.
And that's why we do N, En.
Okay, pretty simple, not too hard.
So far, so good. Kind of
Okay.
I'm getting it.
So I'm going to add another one. Because, it's getting too easy now.
Yo, can you grade our last test before the next test so that I know how much effort?
I'm going to try. Believe me, I'm not putting it off on purpose. There's other things that other timelines have come up that are priorities, unfortunately. I'm sorry, you're a priority, Nate, but
I am
there's some other things that have come up that have been major priorities.
I'm
So
calculating my anticipated energy expenditure on the next test.
well, I'm expecting you to give 110% on the next time. That's it.
One part of that formula is how bad am I failing already?
No, it's like if you get 100, then that fixed the problem already, right?
Man, if I got 100, I would just quit the class and give up. I done completed it. I don't even need to finish it.
No, that's not how it works.
It worked. That's how it works in my head.
Yeah.
I'm never gonna get 100 on a test.
Okay, so our next things are esters. Now, esters are just going to be O's
Functional group.
attached to a functional group, single bond to a functional group, single bond to another function. Now, the way that you write an ester is there's 2 ways. I'll show you what is actually commonly used, and then I'll show you the way that IUPAC says they want things commonly used. Okay, both are acceptable for your exam. Okay,
Hmm.
so we'll start off Simple here. Okay. So in this case, you find the longest carbon chain.
4.
Oh, and let me tell you, the suffix is OUA, or it's ester.
Okay. Oh wait. 4
Okay. Oh, I'm sorry. Teaching you the wrong one. I don't want to teach you esters yet. I want to teach you ethers. Okay. Ethers. These are ethers, not esters. And then we'll talk about esters later. Ether.
Is there's only one carbon chain coming off the other side of that oxygen? Does that make it a methyl group, or is it still a carbon chain?
So it's, yeah, that does make it a methyl group since there's only one carbon coming off of it.
Okay.
And then fix this.
The only part of this equation I'm missing is I can't remember how to say 4 in Greek. Three, 4. Ketchup?
So you don't say 4 in Greek, you would actually just say it in, because bute, we use bute in this case. So tetra is how we would say 4 in Greek.
Yeah.
But since we're talking about the hydrocarbons, it'll be bute. Okay, so these guys, now that I've corrected it, so we have our carbon coming off here. So you said this is one carbon off of this side. And then this guy had how many carbons?
4.
Are you sure?
No.
3.
Oh, you don't count where it connect. Oh, because it's connected to the O.
That's right.
Ah.
Okay. So the longest chain gets its name. So then it would be 1, 2, 3. So that's prop. And then you put A and E. You put oxy in front of that prop. So oxy, propanol. I mean, oxypropane. And then you'd put the other one would just be methyl.
Methyl
Or-
oxypropane.
Sorry, meth.
How's this a hydrocarbon? I thought that there has to be hydrogen in it. Is that
There is hydrogens because the carbons, remember the carbons are saturated with hydrogen.
my bad? Dumb
Remember, carbons have 4 bonds
Yeah.
that I can attach to it. If they're all single bonds, they're using all 4 bonds. So then that means there's 2 hydrogens attached there.
Yeah, I remember now.
Okay. So this guy would be called methoxypropane. Or an easier way of doing it is calling it methyl propyl ether.
That doesn't seem easy.
And ether is always going to be because of the oxygen.
What was that?
Is ether going to always be because of the oxygen?
Yes, because it's single bonds to that oxygen.
But what happened to the ane? Is that the YL? Is that showing that there's only single bonds in the propane? That's
Yes. So YL is also meaning that there's only single bonds in that propane. If it was double bonds in there, you'd put ENYL.
I'm gonna screenshot that one.
Okay. So let's say if we have this guy.
Methyl propyl ether.
Dr. Henry, when you put methoxypropane, the oxy comes from the oxygen, or where does that come from?
The oxy comes from the oxygen.
Oh,
You're letting me know that there's an oxygen in between the meth and the propane.
the propane. Okay.
Yep. Okay, what about this guy here? Well, let's make it a little more challenging.
Can't stand when there's oxygen in my meth. Let's see. 1, 2, 3, 4, 5, 7. Hepta. 1, 2, 3. W.
Okay, what is the longest chain?
2.
Hexa?
Okay,
Methyl oxy hep. That's my guess. Oh, 5. Wait, what?
on this side we have,
Oh, it's only 3.
okay, so what would we name this guy?
Well, would you count backwards on that longest chain because of the methyl being off the beginning of that group?
No, okay, so even though with the ester, you'd have to start where the connection is, right? Even though esters are lower in the chain, lower in priority, we'd count where the ester starts off at, as the carbon next to that would be the 1 carbon.
Shortest distance to that methyl group when it's an oxy involved?
Yes,
Okay. 5 methyl.
5-methyl. Okay, so 5-methyl.
Five methyl.
Hexylbutyl. That's Esther.
There's-
Heptaoxybute. Oh, there's only 3. Heptaoxy.
So there's 3. What is a 3-chain carbon called?
Pro.
Oxypropyl.
Okay,
Oh, 3. Oh, 4.
okay, so
Do we have to show the oxygen in the middle though?
yeah, so let me show you, I'll show you how to name it both ways, because this makes it a little more complicated. Okay, so if we're doing the way that we had shown earlier, the meth, so we call this prop, oxy, and then hexane.
Why are you
So-
taking it from the right side to the left side? Is because the shortest chain is on the right side?
Yes,
So it
well,
does-
and then you always put the shortest chain in front, right? In front of the oxy.
and
Do you
then we
understand? The longest chain, the longest chain gets the last name.
right, but we know that the 5-methyl will go on the hexane because it's the only one long enough to handle the 5-methyl.
That's right.
What if you have something that's longer, like
So then in that case, you put parentheses in that prop to let me know that it's that. So that's what I'm going to show you here.
all right,
So in terms of the ethyl, right, it would be called hexyl. So then it would be 5-methyl
5-methyl hexylprexyl mexyl. 5-methyl hexyl.
5-methyl hexyl
Propyl.
propyl ether.
5-methyl hexylpropyl ether.
Dr. Henry, you said the parentheses is to signify the longest chain? Is that what that is?
No, the parentheses are to let me know that the methyl goes with the hexyl.
So if it was like if there was a 6 chain and then like a 7 chain on the other side, and you were to write it the first way of the 5-methyl carboxyhexane, that style or whatever,
Yeah,
you wouldn't be able to write it that style because there's two chains potentially where the methyl could be coming off.
that's right. So then in that context, you'd have to use parentheses to sit there and separate them where the chains are coming off at.
So you'd have to do like 5-methyl hexyl, and then if it was like an 8 chain, like octyl, whatever. Okay. But the top one is still right, and it's only in this instance that it works because one of the chains is short enough that it obviously can't go in
That
there.
is correct. Yeah.
All right. All right. Got it. That's why IUPAC changed it or whatever?
Yeah. Well, it's partially, this is what IUPAC changed it to, right? But it gets a lot of trickiness. This is what most people use because it's a lot easier to write.
And that upper one, it seems like it has limitations then.
Yes,
In other words.
because you have to put where things are located at, and it starts affecting that. So,
Got it.
okay. Oops. Go back. Okay, so we have one more that I want to talk about. Make sure I'm not lying to you. And then we'll put them all on the same screen. And then I want you to help me figure out the families, right? Okay, our last functional group are carboxylic acids. These guys look like this. Okay. So let me give you an example. This is the way it'll be drawn. Can you count the carbon from that? Where the double bond is located is your first carbon, second carbon, third carbon. Excuse me.
Dr. Henry, how come on this one we count it from where it's like joined?
We did it in the other one too, for the aldehydes and the ketones as well too. Well, we started on that as the first carbon. We always start at that first carbon. This is a terminal, so this is always considered the first carbon. The aldehyde, we did exactly the same thing. Remember, it was so. In this case, this is the first carbon. This is the second carbon, and that's the third carbon. Okay, so this guy is count 1, 2, 3. So a three chain carbon is called what?
Propane.
Prop. And then it's all single bonds in that carbon chain. So then it's oic acid. Okay. So this guy would be called propanoic acid.
Carbonic acid.
Dr. Henry.
Yep.
The suffix for this is E EOE?
Yep.
IOC?
IOC, yep. IOC and acid.
Isn't it OIC?
Okay, thank you.
Oh, sorry, yes. I'm mentally backwards. It's OIC, thank you.
You're welcome.
Oops.
It's not your fault, Dr. Henry. I got a cheat sheet.
That's good. I was just checking to see if you're going to use it.
Hell yeah, I'm gonna use it.
Okay. Hit it again. There you go. Propanoic acid. Oh, wait. Thank you, Veronica and Nate.
No problem.
Okay. So propanoic acid. Okay. So what would this guy be?
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 5 methyl heptanoic acid. Heptanoic acid. 5 methyl heptanoic. It's all single chains. 5 methyl heptanoic acid. That's my guess.
Okay. Questions, concerns, Cash.
No, that one's. That's not too bad.
Not too bad. Okay. Okay, so this is your list. Tell me which. So these are the families. Tell me which family this guy belongs to. And name it.
Oh, double bond. Let's see on my list. Oh, double bond. Well, would that bond between O and H be a single bond, and then O is a double bond because the other bond is with a carbon chain?
Which one are you making reference to?
The one on the top left, how it has O and then a double bond, and then one of them goes off to a H.
So that would be, you're saying this is a carbon right here.
Right. So is between the O and the H, is that just one single bond?
Between the carbon and this hydrogen, yes, that's a single bond.
Oh, it's
Because H can't form a double bond, right?
okay. I guess what I'm saying is between the oxygen to the carbon, then is
Uh-huh.
a single bond like one direction and a single bond the other direction, so it's a double bond.
That's right. So this guy's a single bond.
Right.
This guy's a double bond this direction. This way, that's a double bond. This is a single bond. This is a single bond. So it's literally, it's carbon going like this.
Okay.
To the other carbon.
Oh, okay. I see what it is. All right. Oh, carbon hydrogen. So it's an aldehyde. So
Let's see.
1, 2, 3, 4, 5. Is that first one just pentanol?
One, two, three, 4, 5. Spell it for me.
Pentanal?
Pentanal.
Yeah, I think so.
Okay.
I feel pretty confident. I would turn that in on a test for potentially half credit. Oh. Edgar's probably done already. I'm on number 2.
Not done.
I know you're done, Edgar. He hasn't even written the equations yet. You're probably done.
No, not this time.
Oh. Oh, ether. That's just ether. Count the middle carbon going both directions or just one time?
You only count the middle carbon once.
Okay, so you can only
One and done.
only count it for the longest chain.
That's right.
Okay. 1, 2, 3, 4, 5. Oh, going down with a double bond.
So Nate, you said the first one was an aldehyde.
Pretty sure, yeah. I don't want to commit to my answers at the moment, but yes, that's what I said.
Okay. Okay, what about B? What's the name for B? Somebody's already on top of it. Let's see.
I think
Get
it's
caught up.
For B,
For B.
I think I got oxydimethane. If that works.
My vote is for ether. He's probably right though.
Because using the naming convention, I got methoxymethane, and I'm like, that doesn't sound right.
Okay. So, and then it would be dimethyl ether. So either of those would be okay.
Yeah, so I just got dimethyl ether without the top
Yeah.
part.
Yeah, that'll be
Isn't
fine.
That
Yeah.
functional group's not already named though, isn't it already named?
What was that?
That functional group's already named though, isn't it? Like when we
Dimethyl ether?
no, just the oxygen with 2 carbon chains coming off of it.
Yeah, what is it called? What is the family called?
Ether. But
Ether.
isn't that an example of ether?
Yeah, this is an example of an ether, but that is an ether, dimethyl ether.
So what's ether look like just by itself? Is there such thing?
No, because ether refers to just that class. You have to tell me specifically what it is.
I thought the
Oh.
structure was named ether, like how we have other, like on the
Yeah.
ions,
So,
compounds that are named already. That's
but
what
it's not. So ether, again, ether is a general term, right? So the dimethyl ether
right.
is typically, they'll say ether for it, but you have to say dimethyl ether because it could be diethyl ether as well too, right?
Right. That's what
And both of them are very common.
Gotcha.
So, but people would just say ether in general, right? There's no reference to which one. Okay. What about C?
C is a ketone group, I think.
I agree with Nate.
I would say like pentylpropone. One, two, three, four, five.
I got
pentane propone.
4 octanone.
Okay, now I'm confused.
Longest carbon chain.
I counted it off both sides.
Yeah, the reason for like ethers you counted on both sides, Nate, is like the carbons are chaining off of the oxygen, whereas in that one, there's still a carbon there. It's just double bonded to an oxygen.
I got you. So the oxygen is like a branch.
Yeah,
Yep.
the oxygen's a branch.
Oh, I'm dumb. I'm super dumb. Is there a class before Chem 101 that I could go to?
Okay. D. What family?
Alcohol?
We'll put the families in green. Well, oops, maybe. Oops.
Is it an imine group?
Amine. Amine?
Amine?
Yeah. It is an amine.
Amine.
Oh.
All right.
I was looking at E.
I don't even know how to count that. One, two. Is there 2 carbons coming off of each of those chains since they're connected to the nitrogen?
Yep.
Yeah.
Okay.
So what would be the name? Christine. What was that? I heard it. Ethylamine. Okay.
Triethylamine. Yeah, that's not what I got.
Oops.
Ugh.
Okay. E. What family?
Alcohol?
What's the name?
Hexanol? Oh, wait. Yeah, I'm going with that. I'm going with a 6 carbon chain.
5, 6.
So 3 hexanol.
Okay. F.
Wait, I got that right? Can I get some confirmation here?
Yes,
That's correct. All right.
that is correct.
1, 2, 3, 4.
Dr. Henry,
Yes.
okay, with the alcohol, why are you not counting kind of like the ether? Why are you not counting? Oh my gosh, let me annotate this.
2-methyl.
Okay. Okay, so why are you not counting like let's say, 1, 2, 3, then like 1, 2 here?
No,
It's
because
like
it's always, you count it on the longest carbon chain, right?
okay.
So for the alcohol, but you want to try to get it the shortest distance to that functional group.
Okay.
So you would count, put it in blue. 1, 2, 3,
Okay.
4, 5, 6. The ether, right? Because you have an oxygen in between the two chains, right?
Okay.
That's one chain and another chain. So literally, this is what this looks like. It's O attached to that carbon, attached to this other carbon, and of course you have the hydrogens surrounding it, right? So that's what that ether looks like, right? So there's an O between it. Here you have carbon attached to the oxygen, which is attached to the hydrogen, and then this is attached to other carbons. Do you see the difference?
Yes, I do. But I'm still struggling to understand it. When I finish watching like the past lecture videos, I will fully understand.
Yeah.
Yeah.
There's
Thank
a
you.
lot. Yep.
Yeah.
Is F 2-methylhexene?
You said it's what?
Is it 2-methylhexene?
Wait, I thought that would be like the old ones where it's like 5-methyl-1,3-hexene.
I got the same as Brittany.
Hey, double bonds, right? You're probably right.
Are you talking about F?
Yeah, we're talking about.
Yeah.
Okay.
Oh yeah, she's. I think she's right. You got to count the double bonds, right? So it's like
Yeah, 5-methyl-1-3-hexene.
Dihexene.
We count it from left to right because the double bond gets priority and it's on the first carbon. Is that why?
Yep. The double bond's on the first carbon, so we count it from this way, right?
Yeah, so it's on 1 and 3. The
Counted
two
it as
double.
methyl chain. Thank you, Brittany.
No problem, Nate.
So you said it's 1, 3.
I think we put 5-methyl first. 5-methyl-1,3-hexene.
You said no?
I said, no, I said, oh,
Oh, okay.
But I guess wouldn't the 1,3 take priority? Well, no, because we have to end with hexene. So yeah, that's right.
Or do double bonds take priority?
But we got to end it with the hexene.
is it hexene?
Yeah, I think it's ene. E-N-E. Oh, I don't know about now. Oh, di. Oh, dang it. Hexadi.
Oh, yeah, dihexene for the 2.
Yep.
Even though we put 2 numbers, we got to say it again. Say it twice.
Yeah, because you have to give me the numbers, give me the location. The die lets me know that there are 2, right?
If you read 1, 3, 6, and 4, you know there's 4 of them.
You would assume that, right? But
Yeah, I got you. Hexadiene.
Yeah.
5-methyl-1,3-hexadiene. Okay.
hey, what family?
That's
Alkene.
alkene. Yeah.
Oops, that's right. Oh, crap. Type it again.
5-methyl-hexadiene. All right. 1, 2, 3, 4, 5, 6, 7, 8. A triple bond.
Alkane.
So is I like an example of what you did earlier, like the whole carboxylic acid?
Carboxylic acid, that's right.
I feel like there could be a whole class for each one of these things we've learned so far.
There is a class that's called organic chemistry.
You know what? I was onto something. I knew I was onto something. I was just about to write a note to the dean and be like, you know, we should probably have a class.
Okay, so what would this guy be called? I.
Oh, we're already on I?
Yeah, we'll go back up to G and H in
One,
a second.
1, 2, 3, 4, 5.
Pentanoic acid.
Okay.
Oh, snaps. That was someone different. Come out the cuts. Who was it? Speak up. We want to know who's going to get into the top 6. Pentanoic acid. And that's a carboxylic acid.
Okay, H.
Oh, Lord. Let me see.
What family?
Haloalkane.
Okay, good job.
Ox. What's that branch? What is that? A CL?
Yep.
For that one, I got 3-chloro-2,2-dimethyl-octane.
Jesus.
3. Oops. Come on now. Okay, 3 chloro 2,2 dimethyl.
Ox. Oh.
Ran out of room here.
Yo, this functional group chart says naming hollow, and then the example does not have hollow in it. So that's confusing.
It's hollow, so it's hal for your halogen. Then
Yep.
O, you add the O to it. So like bromine is a halogen, so that the bro or the brome is going to take place of the HAl. Then you're going to add an O to it, so it becomes bromo.
Bromo. Okay.
Yeah. Bromo, fluoro, chloro, iodo.
Oh yeah, Adam, I got that on in the background, bro. I'm waiting for it. I've had it on live stream.
Okay. G for the goal.
1 octane. Octane.
Or is it 1 heptine? Which one?
Let's count.
I got 1 octine.
That's what I got too.
1, 2, 3, 4, 5, 6, 7, 8.
It confuses me, the 1, 2, or the triple.
Because it's that straight structure, right?
Mm-hmm.
Okay. So you guys said 1 octine. And what family? Again?
Alkyne.
Alkyne.
Y'all are all so kind. Okay, perfect. So are you guys ready?
For another one, yeah.
You're ready for another one? I was meaning that you're ready for the exam.
No.
No, what do you mean no?
Just a few more questions, and then we'll have that confidence.
Well, that's all I got on organic chemistry. There are tons of functional groups, not tons, there's more functional groups. But these are the ones that I want you guys to know. These are the ones that you guys are going to come in contact with while we're doing some of the problems. So I want you to be a little bit familiar with it, okay?
I have a feeling that I might do good on this exam.
Okay, one of you guys at a time. So go ahead, Alan, and then Tucker.
I have a feeling that I might do good on this exam.
Okay, you're feeling confident. That's good.
I have a feeling.
Was that what you're feeling too, Tucker? That's what you were saying as well?
I wish it was. I wish I was saying that, but do we have a lab today?
Yes, you actually do have a lab today. I have to post it. I haven't posted it yet. So
okay, cool.
Post. Who's feeling guilty?
What are you talking about?
I saw guilty in a thing, so. Did they really just reach a verdict?
Yeah, I got it on live in the background. My stream's probably like 30 seconds or 40 seconds late, but they found him guilty of 2nd-degree unintentional homicide.
Okay.
Oh, 3rd-degree murder as well.
Oh, really?
Yeah.
Wow.
Wait, on what?
There's an officer, Derek Chauvin, in Minneapolis that like knelt on this guy George Floyd's neck for like 9.5 minutes. And he went to
okay. I got you. I didn't know it was today.
Yeah.
I got you.
Sorry, it's over now. We're just
commenting.
Slight detour, yeah.
Okay, so now you guys are feeling pretty confident. Now let's get down to how you're going to start using this, right? So you've already worked on balancing the chemical equations. You've already done homework 8. I mean, not homework, lab 8. I lose track. The one with naming chemical equations, right? You guys done that already? Yes, no, maybe? Tried it?
Yeah.
Good.
Kinda.
Okay, so I'm gonna kind of regress a little bit because there's a little bit more that I need you guys to know and to understand. So we're gonna go to chapter 7 in the lecture notes. Are you guys ready? Let's see. And everybody got this down? You're good? Feeling confident? So at this point, you're already familiar with how to write chemical formulas. You know how to name chemical formulas, right? The next thing that we're going to be talking about is determining the molar mass. You guys, we've talked about this a little bit, but there are a couple of things that you guys need to remember about those names. Like for instance, sodium nitrate. So if we had to write out what sodium nitrate was, we needed to be sure that you had the sodium, which has a +1 charge, and the nitrate, which has a -1 charge, balanced out, right? So we know that sodium has a +1, nitrate has a -1. They balance each out perfectly, right? So we have one nitrate with one sodium. So that means this formula basically means that we have one sodium atom, we have one nitrogen atom, and we have 3 oxygens. You guys see that, right?
Yes.
Okay. Good. Okay. So how many atoms of each element are in the formula unit ammonium carbonate? First thing I want to do is to write what?
Chemical formula.
What is the chemical formula for ammonium carbonate?
NH4 CO3.
Parentheses, NH4.
NH4, and you said parentheses.
Yes, with a 2 subscript.
Okay.
CO3.
CO3. So why do I need 2 ammoniums?
To balance out the charge.
To balance out the charge of the carbonate. We know that carbonate has a -2 charge. We know that ammonium has a +1 charge, right? And you guys know this from your polyatomic ion table, or you've kind of ingrained it in your head because you've seen ammonium thousands of times already, right? Okay, so how many atoms of each do I have in this chemical formula? How many nitrogen atoms do I have?
2.
How many hydrogen atoms do I have?
8.
8.
8.
How many carbons do I have?
1.
1.
And how many oxygens do I have?
3.
3.
3.
Okay, so now this is where your periodic table comes in. So nitrogen has a specific mass associated. This mass is called the atomic mass, right? So when we talk about a single, let's say a single, in this case, a single compound or a single molecule, we're talking about individual ones, right? Not as a whole. So we look in that case in terms of the atomic mass units, AMU, right? And that's represented on our periodic table. How much does nitrogen weigh on our periodic table?
14.007.
Okay, so it weighs 14.007. Okay, and we have how many nitrogens?
2.
2.
So 2 times. So that's 28.014. What about hydrogen?
1.008.
1.008.
That would be 8.064.
Carbon?
12.011.
Oxygen?
It's 15.999, but can we just say 16 or no? You have to put it as 15.999.
That is a very good question. So if you actually look at your periodic table compared to another person's periodic table compared to another person's periodic table, those numbers are rounded up frequently. So some cases it'll say 16, some cases it'll say 15.999999. So you could get away with saying 16, right? But you know that these numbers are I shouldn't say estimated, but they've been rounded, right? So you know you can't use those for significant figures. You don't want to ever use those for significant figures. So we could just say 16. So 16 times 3.
That's 48.
48.
Okay. So to calculate the mass of this compound, we'd add them all together. So what do you guys get when you add them all together?
96.089.
And those units are going to be atomic mass units because we're talking on that level. Now, we can also use what we call grams per mole. That means I kind of have to explain the mole to you. Okay, so you guys know what a dozen is?
12.
Ounces.
So a dozen equals 12. So does it make reference to anything? Can I have a dozen of shoes? Dozen of cats? Dozen of wives? Dozen of husbands? Dozen of girlfriends? Dozen of donuts? Right? So it could be, it makes reference to anything. Donuts, eggs, jurors, right? So I can have a dozen of anything. Now a mole is just like that. So a mole is going to be equal to 6.022 times 10 to the 23rd. Okay.
Isn't that what we're using the Avogadro's number?
That's right. This is Avogadro's number. Yeah, it's pretty big. Okay. Okay. So 6.022 times 10 to the 23rd. That's what a mole is equal to. Okay. So because we're working with atoms, right? Now, you guys can't sit there and weigh a single atom or a single molecule, can you? And see it? Do you feel confident? Say, okay, I got one right there.
No.
No. So we have to put it in something that we're able to touch, visualize, and to utilize, right? Easily, right? So we add a whole bunch of these molecules, a mole of them, to sit there and make it so that we could actually work with it. Does that make sense? Yes, no, maybe?
Yes, it makes sense.
A little bit.
A little bit. Now, it's not that hard. Don't overthink it. So a mole is just giving you a whole bunch of these atoms together, right? So that we can actually weigh it on a scale. We can actually sit there and put it in our coffee, sugar, you know, or in our food if it's salt, right? Otherwise, you're not putting a single salt molecule on your meat, are you? You're putting a whole bunch, right?
Yeah.
Okay. So we need it so that we're able to utilize it. So that's what a mole does. It allows us to utilize it. And this is Avogadro's number, often called I misspelled that like crazy. I'll fix it here in a second. Okay. Avogadro's number. And it's
I remember saying
always gonna,
Avogadro's number.
yeah, a lot of people do say avocado's number. But it's always going to be that same value, just like a dozen. Okay. And it makes reference to quantity, just like a dozen. 12, right? It's not mass, it's quantity. So Avogadro's number makes reference to quantity, the number that you have. So we need a way of converting quantity into grams. And so we use our molar mass. Molar mass, that term, molar mass, moles, and mass, which is grams. So that's why we use grams per mole. Okay. So our periodic table gives us our molar mass, or it gives us atomic mass units. Are you with me?
Yes.
Good.
Yes.
Okay. So this would be either the molar mass or the atomic mass units of ammonium carbonate. Okay. Okay. Now, the term molecular mass makes reference to the molecule, like things that are covalently bonded together, right? Molecular mass, right? And then formula mass, actually, no. Molecular mass makes use to things that are ionic. So basically, you're getting the average mass of the components that are being added together. Formula mass makes use of the compound, something that's one unit of substance, right? So what we just calculated, since it was an ionic compound, that would be called the molecular mass. We calculated the molecular mass, and that would be, or we would say, atomic mass. If we were talking about the atom itself, that guy would be the molecular mass. Now, the reason why, and this is more so for people who want to go into chemistry. Molecular mass and formula mass are essentially the same, but molecular mass makes reference to taking the average of the number of molecules, the mass of the number of molecules that are going to be in this complex. Because when we talk about things like sodium chloride is interacting based upon charges, plus and minuses, right? And you're forming this lattice and all this stuff. So ultimately, you're getting something like this, right? All of these guys that are connected to each other by charge, right? So we take the average of that, and if we just take the average of that, the average mass of that, of the sodium and the chloride, we know that there's going to be one sodium to every chloride based upon the average, okay? So then the molar mass, or I'm sorry, the molecular mass of sodium chloride would be what is the mass of sodium?
22.99.
22.99. And then chloride?
35.45.
Okay, 58.44 and AMU, atomic mass units. Okay, so the way that we calculate it is going to be exactly the same. The difference is that in this case, we're just taking the average. So we're just taking a look because we know that it's a 1-to-1 ratio between sodium and chloride, even though it forms this nice crystal lattice. Does that make sense?
Kinda.
Okay, so let me make it a little more simpler. So when we talk about the formula unit, the formula mass, these guys are covalently bonded together. That's one unit. This is carbon dioxide, CO2. We know that oxygen weighs 16, roughly. Carbon, 12.01. And the other oxygen weighs 16. That's one unit. It works as a single unit by itself. It's all connected to itself. Where in the case of, okay, how many of you guys play with Legos?
Used to.
Used to. Don't lie, you know you still do. I saw that Lego box in your room on Zoom.
Ah.
So, have you guys ever played with Legos?
Yes.
Yes.
Okay. So,
It was. Sorry,
was that?
What did you say? What game?
Legos. Have you ever played with
Oh, okay.
Legos?
Oh, no,
Legos.
never.
You never
Never.
played with Legos?
Yes.
So we've got to get you some Legos to play with. Okay. Now,
No, don't worry.
now, what you guys do with Legos, you basically take one unit, it's one unit by itself, right? And you use that unit to sit there and build whatever you want to build. I want to build a ship, you know, the Death Star, whatever. So I use tons and tons of Legos to sit there and do it, but they're all single units, right?
Right.
They're not connected as a whole. Is that right?
Right.
Mhm.
So they're modular in that sense, right? So that's kind of like what you're getting here, right? Let me go back. Oops. In the case of our sodium chloride, you have your sodium, and it's going to be connecting to that next Lego piece, which is the chloride, which is going to be connected to the next Lego piece, which is the sodium, right? And so we're just getting alternating of those pieces, right? But you have all of those pieces together, but we're just getting the average weight of one piece together, that sodium and the chloride. Does that make sense?
It does.
Okay. Where here, this is one unit that's connected, right? They're physically connected. They're sharing those bonds, so they're connected. So that's going to give us our formula mass. And this is going to give us our molecular mass. Okay? Are you with me?
Yeah.
Yeah.
Okay.
I think so.
So ultimately, at the end of the day, if you're not a chemist, don't get hung up on formula mass versus molecular mass. You're going to calculate it the same way. Sodium chloride, NaCl, one sodium, one chloride. You're going to use that to calculate the mass. Carbon dioxide, one carbon, two oxygens. You're going to use that to calculate the mass. Okay? Calculate the formula mass of ammonium nitrate. So what am I going to start with? What's the first thing I'm going to do?
Find ammonium and find nitrate.
H4NO3.
NH4. And you said NO3?
Yes. And they're already balanced out because they have a charge of +1 and -1.
Good job. Good job, Daisy. Okay. So how many nitrogens do I have?
2.
2,
How many hydrogens do I have?
3.
4.
No, 4. Sorry, I'm tired.
How many oxygens do I have?
3.
Okay. So what am I going to do now?
Find it on the
Periodic
table
table.
in the back.
Okay. I'll translate. All you guys said it differently, but same thing. Find it on the periodic table, right? So nitrogen, how much does nitrogen weigh?
14.007.
So we're going to cheat. We're just going to say 14. Is that okay?
Okay. Yes.
Okay. How much does the hydrogen weigh?
1.008.
So I'm going to say 4 times 1. Is that cool?
Yep.
Yeah.
And how much does the oxygen weigh?
16.
10.999.
So, okay, for 60. Okay,
Okay.
3 times 16.
48.
48.
4 times 1.
4.
And 2 times 14.
28.
28.
That's 80.
Oops.
AMU.
AMU. Yep.